Now you've practiced the rules, you've got to recognise when to use the rules, because they're not going to say use the sine rule to find. And I mentioned in the last video that the sine rule is if I've got one side and two angles, or two sides. Look, I go two sides, two angles, including the unknown. Two sides, two angles, including the unknown. And the cosine rule, three sides, one angle, including the unknown. That's how I do it. Okay. The angle of elevation from a tower. From a tower is 72 degrees from A. From B, 50 metres further away. This is 50, B. The angle of elevation is 47. Find the exact length of AT. Right. Well, I've got 50 and I've got this angle is 72, so this one's 108. And if this is 108 and this is 47, the one up the top is 25. So using this triangle, I could do the sine rule to find this side. So I could, let's call it x. X on sine 47 equals 50 on sine 25. And when I put in my calculator, sine 47 times 50 divided by sine 25, I get 86.5. Now I've got a right angle triangle with this angle opposite over hypotenuse. So again, it's sine 72 is my unknown, we'll call it AT. Opposite over hypotenuse, I just found that, 86.5. So I can find that AT is 86.5 times sine 72, which is 82 meters. Hence find the, or otherwise find the height. Oh, I already found the height. Find the exact length of AT. Oh, okay. I found this, so I did, that's part A, this is part B. I found the height of the height of the tower. Have a look at number 2. The ship sails from Sydney for 200 on a bearing of 40 degrees, so I need 40 for 200 kilometres. Then sails on a bearing of 157, which is out here, which makes this angle here 67 because it's to 90, so it makes this one 23. I know this one's 40 because of alternate angles, and it travels to 345 kilometres. This is Sydney. How far from Sydney is the ship now? So what it's asking you to find is this. Two sides, an inclusive angle, cosine rule, AB cos C, 200 squared plus 345 squared minus 2 times 200 times 345 times cos 63 degrees. Don't forget to square root it. And I get 310 kilometres. What is the bearing of the ship from Sydney? Okay, let's come over here. I need to know what this angle is here. So if I find this angle, I know that this one's 23. I know that to here's 270. Okay, I found this theta. I changed colour so it would be a bit clearer. I found this theta by going sine theta on 200 is equal to sine 63 on x, which we know is 310. and I've used a sine rule. I found that it's 35 degrees. Now the question is, what is the bearing around here? Well, the bearing is 360 degrees minus this 23, because we know that because of alternate angles, minus the 35, and that will give you your answer. 302 degrees.